These are the solutions for the practice test for test 1 of quarter 2 for math 6. So let's take a look at our first problem. And it asks us to divide. And so I see the division problem already set up for me. So I'm going to go ahead and try the division. Now, I look at 52 and it does not go into 2. It does not go into 21, but it does go into 218. So my first number is going to go right above the 8. So I need to figure out how many times does 52 go into 218. So what I'm going to end up doing is some estimation. And so here's how I do it. I'm going to think of 52 into 218, but what I'll do is I'll cross off this 2, and I'll cross off this 8, and just think of 5 into 21. And so I see that 5 goes into 21 4 times. So that gives me a place to start. So this is my starting point. So what I'll end up doing is I'll try a 4, and I'll multiply it by 52 and see what that ends up being. So I multiply, and I end up with 8, and this makes 20, so 208, and that is fairly close. So that's what we'll go with. So what a 4 right above the 8, and 4 times 52, as we did before, makes 208. I do the subtraction, I'm left with 10 left over. And so I'm going to bring down this 4, and now I have to do 52 into 104. So I do the same thing. Again, you're doing 52 into 104, but to do an estimation, you're just going to cross off this 2 and cross off this 4 and think of 5 into 10. Well, that goes in there 2 times. So then we try it. We try 54 multiplied by 2 to see what we end up coming up with. And when we do that, we end up, actually, let's see, it's not 54, it's 52, so let's fix that real quick. And so I have 52 multiplied by the 2, and that gives me 104, the exact number I needed. And so we'll go ahead and write that in there. So I put a 2 here, and again, we've already done 2 times 52, and that does make 104. Do the subtraction, we've got 0 as a remainder. That means we're done with the problem. And so our answer, our quotient, is 42. And so the next one, we're trying to add these two numbers, and whenever we add decimals, we need to line up decimal points. So I'm going to start out the problem off this way. 9 47 hundredths plus 205 thousandths. The 5 is in the thousandths place, so that's the way I read it. Now I'm adding. Now again, notice that I've lined up the decimals, and I'll add some placeholders. Zeros are placeholders. It doesn't change the value of the number, it's just shows you that there's a number right at that spot. And I'm going to add another placeholder here if I want it to as well. And so now I add. Now when I add, I'm just adding up place values. So this makes 5, 7 and 0 is 7, 4 and 2 is 6. Bring the decimal point straight down and add those two numbers, and there it is. So our number is 9 and, so whenever I see that decimal point, that's the word I use. So 9 and 675 thousandths. Well, here's a subtraction problem. Again, it's the same as addition. You're lining up decimal points. And so when I do that, I'll line up those decimal points and I'll do the subtraction. Now, before I finish it, or before I can start it, I need to add in a placeholder here of 0 and do that subtraction. And when I do that, I got to have the bigger number on top. If I don't, that means I need to borrow. So I'm going to end up borrowing back all the way from this ones place. So from the 2, and I'm going to change that to a 1. Now I've got to borrow back and change this to a 14. The 14 will change to a 13, and now we're ready to do the subtraction. So I'll go ahead and subtract 1 from 10, that makes 9. And then 13 minus 8 gives me 5. 14 minus 9 gives me another 5. Now to bring down that decimal point and bring down the 1. 1 minus 0 is 1. So there's my number. 1 and 559 thousandths is how we read that. Well, here it asks us to find the greatest common divisor between these two numbers. And so when we're doing greatest common divisor, I like to break down the numbers. A couple ways you can do it. You can list factors, or you can factor. And I'm going to use this factor tree method. And so when I do that, I see that 5 times 2 makes 10. Here I see 5 times by 10 makes 50. Now, some people will see right away, oh, I see the answer. But if you don't, then continue to break this down. 5 and 2 make 10, and I'll bring down this other 5. So now this is the prime factored form for each of those. We're trying to find the greatest common divisor, otherwise known as GCD. It's also called the greatest common factor as well. So what you're doing is you're looking for numbers in common. That's why they call it the common divisor. So the greatest one's the biggest number. So for instance, 5 is a factor of both of these. See, 5 goes into 10, 5 goes into 50 as well. So 5 is one of the factors, but it's not the greatest one. The greatest one is 10. Because you see, I can take a 2 as a common factor as well. And they both share that. So we have a 5 and 2, and that's what's in common. So you multiply those two numbers, and that's, again, how we're getting 10. The next problem asks us to find the least common multiple. Now, again, it's common, means that, and it's a multiple. That means that 12 and 8 are factors. These numbers are going to be factors, and typically they're going to be smaller. Once in a while, you'll get one of the numbers to be the least common multiple, but not in this case. And so we're trying to find the smallest number that these are both factors of. So what we'll do is the same sort of process. We'll break these down to the prime factored form. And once I do that, move on to the next one. And sometimes when you look for the common factor, you can stop right there. But if you don't see that, you have to continue to break those down. So typically what I do is I just take one of the numbers. I like to take the biggest one, and I write down all the factors. 2, 2, and 3. Those are the numbers that make up 12. So now we have 12 goes into this bigger number. But we're not done yet because 8 doesn't go in there. Because 8 needs 3 2's, but I only have 2 2's. So that means I need to add on an extra 2. So now I've got 12. That's one of the factors. But I also have 8. Now here's where I get 8 from. 2 times 2, and this 2 here. That makes 8. And so now you just multiply those numbers to see what you come up with. We do that, and that's 24. And see, 24 is a bigger number. It's a multiple of 12 and 8, and 12 and 8 are both factors of 24. So you can divide 8 into 24. We can also divide 12 into 24 as well. Well, the next problem asks us to write as an improper fraction. So the way we do that is we take the whole number, we multiply it by the divisor, and we add the numerator. And then we go ahead and write it over the divisor. So the key is to multiply first. 6 times 5 makes 30, and then add the 3, and it's all over 5. So the answer is 33 fifths. Let's move on to the next section here, and here's the next problem on the bottom row. It says to write as a mixed number. And so notice that we've got a negative sign, so our answer is going to have that negative sign in there. So I'll start with that, and then I'll go ahead and do the division. So I'm dividing 7 into 36. Well, 7 goes into 36 5 times. And when I go ahead and do that multiplication, I get 35. 5 times 7 is 35. Subtract, I get 1 left over. So the way you do that is you write the whole number, 5, and the remainder is the numerator of the fraction. So 1 over the denominator, 7. So I get that 7 by using whatever the divisor is. So negative 5 and 1/7 is the answer. Next problem says Ted's teacher gives 12 questions, 12 question tests. Ed's teacher gives more frequent 10 question tests. Both teachers give the same number of quiz questions each year. What is the minimum number of quiz questions Ted and Ed could expect in a year? Okay, so the key word here is same number. And so that means that we need to find a multiple of 12 and 10, where 12 and 10 are both factors. So we need to find a number that 12 goes into and 10 goes into that is the same. And so again, the key word is same. So this means we're dealing with the least common multiple. So what we need to do first is break these numbers down. So take that 12. 6 and 2 make 12. Well, we also have 2 and 3 make 6, and bring down that other 2. And so here we have 2 and 5. So I like to start with the bigger number. Least common multiple is going to have a 2, a 3, and a 2. So there's 12. Now we need to make 10. Well, 10 has a 2, but it also has a 5, and we don't have that 5. So I need to write that in there as well. And now we've got the factors. See, right here is 12, and then over with the 2 and the 5 makes 10. So I go ahead and multiply those numbers. That gives me 60. So 60 is the smallest number that 12 goes into and 10 goes into. So 60 questions, giving me some units that go with the problem. That is the answer. Well, that's the smallest number of questions they could have, but I'm sure the teacher will give them more. Here it says Al bought one package of 80 folders and one package of 95 glue sticks. Al wants to use all the glue sticks and folders to create identical sets. So identical sets means that we're going to have a bunch of folders and a bunch of glue sticks together as one set. And then we'll have another set with the same number of folders and the same number of glue sticks. We want to find out what is the greatest number of identical sets. Well, when they use the word greatest, that's a clue that they're talking about the GCF, just like, or the GCD is what we've been calling it in this class. So GCD, greatest common divisor. So the word same meant least common multiple. The greatest gives it away that it's the greatest common divisor. So just take that 80, take the 95, and break those numbers down. Well, 5 multiplied by 16 makes 80. Where when I multiply 5 by 19, I get 95. Well, I could break the 16 down even further, but it doesn't do us much good, because when we had broken down that 95 to 5 and 19, those are both prime numbers. So we look to see what is in common. What is the biggest common divisor? Well, we look at those numbers, and the only number we see is 5. That's what's in common. So that means we have 5 identical sets. So, those are the types of problems that you're going to see on this week's test. Good luck.